So, the past few lessons were about getting us situated. First one was about the program we're using, which is PyCharm. The second one was just about what a Python program looks like at its most basic and how we want it to run a Python program properly at its most basic. From now on, we're going to start talking about the actual programming pieces, and these are things that are going to be about Python, but not exclusively related to Python. Theoretically, you could, or you will, carry these forward into other programming languages. So, to begin with, what the heck is the purpose of programming? And the point of programming, very simple, at least my definition of it, is to manipulate data. All that programming does is it translates information to keep track of different information, move it around from point A to point B, and to do stuff based on the effects of that information. That's all we're doing. So, for example, the screen that you're watching this on right now, the way it knows which pixels to color certain ways, or signals are getting sent to your video card and through your video card. Your video card is doing a lot of complicated math, and it results in calculating, so the pixel should be going to, like, this color should go to the screen, that signal goes through a cable, VGA to HDMI to mini display or display, whatever you've got going on, and that cable says, okay, great, then I'm flipping that pixel. So all that stuff gets translated, and it gets translated through a lot of different layers, but at the end of the day, it's just it's just giving it some information, which, for example, are the color values of a given pixel, which is just a couple of different numbers. Or it's the or if it's a calculator, it's just the value of different numbers and what to add to what, and then do that operation. And at the end of the day, all your computer does is it adds numbers together, and it gets better or worse at adding, like, CPUs versus GPUs, which is, the computer's processing unit is a central processing unit, the computer's brain versus, like, the GPU, the graphical processing unit, which is the video card's brain. Those are just going to be better at processing different pieces of information. But at the end of the day, all that they're doing is processing information. And so you've got these... when we write programs, we start with something very simple. We start with data. Because if we're going to manipulate information, we need to have the information to manipulate. And so the first thing you're going to understand is that programming languages have different data types that we work with. Different programming languages have different ways of identifying them, but at its core, we have a couple of very basic data types. There's going to be numbers, there's going to be strings. Strings are collections of letters. So there's just numbers, collections of letters, but really it means collections of characters. And we've seen strings already. I'll show you a string in a moment. And then we've got what's called a Boolean. A Boolean is a true or false statement. So it's either the word true or the word false. Basically, a lot of the stuff we do in programming is we do logical statements. And the statement we had last time, right, the if you look at one of the scripts that we did last time, right, the if name equals main, that's actually a Boolean, that's a logical statement. If this equals to this, why it's two equal sign, you'll see in a moment. But if this equals to this, so if those two things are equivalent, then we do the following. That's a logical statement. So when we do logic, we always have to get back to a core logical thing. Is this true or is this false? And so we have a data type called a Boolean, which only has two values. It's either true or false, 1 or 0, on or off. And that is our third main data type. Now, numbers, there's different kinds of numbers. There's numbers with a decimal point and without a decimal point. And if you use different programming languages, it can get more elaborate than that. So a number with a decimal point is called a float. A number without a decimal point is called an int. And we can obviously make lists with different things in them. And there's different kinds of lists depending on what we're doing. But at its core, we're dealing with three basic data types. Numbers, strings, and Booleans. So I'm going to show you what those look like. So I'm going to create a new directory here. I'm going to call it lesson 02. And we're going to create a new Python file. And I'm going to point out just really quickly the difference between creating a file and a Python file is whether or not I have to write .py at the end. So we're going to create a Python file here, and I'm going to call it Datatypes, because that's what this lesson's about right now. It's about data types. So when I write a program, one of the other thing, so first of all, we just have a data. So we just have some data types. So for example, if I have the number, that's a number, that's an integer. In this case, it's just a 20. If I write 2.5. This is a different kind of number. This is a float. So one's a regular, one's called an integer because it's a whole number. One is called a float because it's a number with a decimal place in it. Now this can be a negative number, right? But that doesn't actually change anything. It's still just a number. Then the next thing we have is a string, right? So a string has to start with quotes. They can be single quotes or double quotes. We always have to have quotes for a string, and that string can have words and spaces. Like, for example, hello world is the common thing everyone learns to print in every programming language, at least at first. And so this is one data type. This is a number, right? Lines 1 and 2 are one data type. They're a number. And line 4 is a different data type. It is a string. Now, right now, this is just information in a program. Nothing's being done with that information, and that is a problem. The last type of data we said is a Boolean. So a Boolean is either true or false. You'll notice how there's no quote marks here, because when we use Booleans, we do not include quote marks because we don't want it to read it as a string. The moment that you put double quotes, Python says, oh, okay, this is a string, which means I ignore what's inside of it, and I just treat it as a bunch of random characters. So we have the start of the string, the end of the string, and the stuff in the middle doesn't get read, it just gets stored as the characters that it is. A Boolean, though, we want it to actually read it as this special fancy data type, and so we have the word true and false with a capital starting letter. Those are my Boolean. If I write the word false with lowercase, it's not going to work. You will have a class where you're doing JavaScript. In JavaScript, false is supposed to start with lowercase and true starts with lowercase. Booleans in JavaScript are lowercase, Booleans in Python are capital, and that is where things begin to get confusing. Things can get a lot more confusing along the way, but these are our data types. One more thing I'm going to talk about when we talk about related to data types, I'm going to talk about comments. So here you'll notice if I just do that, which is control / this slash, whichever one it is, in PyCharm and in a lot of other programming languages, this is a comment. So comment is not code. It is stuff you write in a program for other programmers to read. So for example, I want you all to read this. I'm going to say numbers. And this is going to be an integer, and oops, it's supposed to be 2 spaces, and this is going to be a float, and this is a string, and these are Booleans. Whoops, Booleans. And there's a typo, sorry about that. PyCharm is nice because it will actually check for typos. Now, you'll notice that PyCharm keeps like popping up little things here. This is not useful necessarily because this is the data, right? And I've given you comments to tell you the different kinds of data types. The trouble with just having this code by itself is that we can't access this information later because we don't have any way of referencing this information. The next lesson is going to talk about variables, which is how we reference information. But for now, just know that these data types exist, and at its core, programming is about manipulating data. And in order for us to manipulate data, we have to know the kind of data we're manipulating. So we've got numbers, which is what we can do math on. We've got strings, which we can analyze and add together and take pieces out of. And we've got Booleans, which is what we do logic with. So numbers for math, Booleans for logic, strings for presenting information to people. And as always, if you have any questions, feel free to ask. I will be around to answer them.